Leaving Cert Higher Level 2019, Paper 1, Question 8. So the weekly revenue, it says here, produced by a company manufacturing air conditioning units is seasonal. The revenue in euro can be approximated by the function R of t is 22,500 cos of pi over 26t plus 37,500, where t is greater than 0. So it says where t is the number of weeks measured from the beginning of July, and pi over 26t is in radians. And part A here says, find the approximate revenue produced 20 weeks after the beginning of July. Give your answer correct, the nearest euro. So it's just looking for the revenue. The R of t here represents the revenue, and then t represents the number of weeks from the beginning of July. So if we're looking for the revenue of 20 weeks after the beginning of July, all we have to do here is replace t with 20. So they're looking here for R of 20. So R of 20 is going to then be, just replace t with 20. So we're going to have here 22,500 cos of 20 pi over 26 by 20. So let's say multiply that by 20 plus then 37,500. And really this can be typed into the calculator in one go. But if you're typing this into the calculator in one go, make sure that your calculator is in radian mode. So when we put that into the calculator, making sure the calculator is in radian mode. Right, okay, so we're going to get, well, rounded to the nearest cent, you're going to get this. You're going to get 20,658.51. But they want it to the nearest euro, so to the nearest euro then you will be looking at 20,659. Alright. So that's part A completed. Now part B here says, find the two values of the time t within the first 52 weeks when the revenue is approximately 26,250. Right. Okay, so that question's asking this really. It's saying what time is it, or how long after the beginning of July is it when the revenue is 26,250. So it's saying t equals what when the revenue is 26,250. So we just have to use the same function as earlier, but this time not to get the revenue but to get the time. So the function that we had earlier was this here, 22,500 cos of pi over 26t plus then 37,500. So that's the function that we're given. Again, we're looking here for the time. What time is it when the revenue is 26,250? So we're going to replace the left hand side here with 26,250, and then the only unknown in this equation is t. So then we should be able to solve for t then. So we've got three terms here in this equation. Now we want to isolate the one that has t in it, so that's the middle one here. So what we can do here is we could bring this over here and this over here. So if I bring this over here, it's going to become then minus 22,500 cos of pi over 26 t is going to equal then, well, it's going to be 37,000 minus 26,250. So that's going to give us then, well, it's going to give us 11,250. And then what we're going to do then is we're going to take this minus 22,500 and divide it into that. So when you divide 11,250 by minus 22,500, that'll actually give you minus a half. So minus, we're going to have this now. So cos of pi over 26t is minus a half. Now, it's looking here for two values of t. So, yeah, within the first 26 or first 52 weeks. So, one way of doing this would be to just temporarily let that angle there be, let it be capital A. So just say we had cos of A was minus a half. So this goes back to trigonometry. Say you had cos of A is minus a half. Now, so then, talking about the unit circle. So if you have your unit circle and you have, just divide it into quadrants here. So this is like 0. I'm going to use radians here. So that'd be 90 degrees or pi over 2 radians. Then pi radians, 3 pi over 2 radians, and so on. Back to 2 pi. Now, so cos is going to be positive in the first quadrant there, because they're all positive there. Only sine is positive there, only tan is positive there, only cos is positive there. So cos is positive in the first and the fourth quadrants, and it's negative in the second and third. Now ours here is negative. So our solution here is going to be, well, one solution is going to be in that quadrant, the other is going to be in that quadrant. So what we could do here is temporarily let, you could say this, you could say just let cos of A, just for the time being, equal plus a half for the purposes of getting the reference angle. So A then has to be the inverse cos of a half. So the inverse cos of a half, again, make sure your calculator is in radian mode for this. You put your calculator in radian mode, it's going to be pi over 3, and that would be equivalent to 60 degrees. But we're going to use that to get the two solutions in these two quadrants. So we're going to come into this quadrant from the horizontal axis by 60 degrees or pi over 3 radians, and come into the third quadrant by pi over 3 radians. So one of our solutions is located here, the other is located there. But the two angles that we're going to be interested in here, they're going to be measured from 0, so that angle there is one solution, this angle here is the other solution. So that smaller angle there is like pi radians, going back by pi over 3. Alright, so then capital A here, going back to this equation, capital A can equal, so it's going to be pi radians minus pi over 3, that's going to give me 2 pi over 3, so A can be 2 pi over 3, or it can be pi radians plus pi over 3, and that's going to give us 4 pi over 3. But earlier we let A be pi over 26t, so let's sub that back in. So pi over 26t then can equal either 2 pi over 3, or it can equal 4 pi over 3. So what we could do here is divide across by pi. Alright, so let's do that first. So then you could say 1/26 of t can equal then 2/3, or it can equal 4/3. So then multiplying across by 26, that's going to mean that t can equal, so when you multiply that by 26, you're going to get, well, it's going to be 52 over 3. So 52 over 3 would be the same thing as 17 and a third. So 17 and a third weeks. So that is one time when the revenue will be that 26,250 figure. Or t can equal, so when you multiply 4/3 by 26, well, that's going to end up being 104/3, and that's going to simplify to 34 2/3 weeks. Okay, so they're the two. That's the two times when the revenue will be 26,250. Okay, and that's part B done. Now on part C here, it wants us to find the derivative of this revenue function. Okay, so differentiating this, I mean, what we have here is we have a constant times a trigonometric function, in this case cos. So when we start differentiating this, whatever happens, that constant of 22,500 would stay there. All we have to do is just concentrate on differentiating the cos function correctly. Now when you differentiate cos of anything, you're going to get minus sine of exactly the same thing. So that thing in this case is pi over 26. So I'm going to get minus sine of pi over 26t, but then I have to multiply by the derivative of that. Okay, now if that was 3t, if I differentiate 3t, I get 3. Differentiate 4t, I get 4. Differentiate pi over 26t, I get pi over 26. So that's that term, differentiate, and I will tidy it up now in a second. And then differentiating this constant, that's just going to go to 0. So when we tidy this up, well, we're going to put the minus in front first, so it's going to be minus, you're going to multiply the 22,500 by this pi over 26, and you want to kind of write that in its simplest form. So in its simplest form, it's going to end up being 11,250 pi over 13. That's what we get when we multiply that constant there by this constant at the end. Then times sine of pi over 26t. And that is the derivative of the revenue function. Alright. Now in part D here it says use calculus to show that the revenue is increasing 30 weeks after the beginning of July. Well, a function is increasing when its first derivative is greater than 0. So what that question is asking us to do, we need to show that when the derivative, the first derivative when t is 30 is greater than 0, that it's positive, right? So our job is to show that r dash of 30 is greater than 0. That is our job. That is what that question was asking. Now, we got the first derivative a second ago, it was that. All we now have to do is replace t there with 30 and just verify that it's positive. So, let's get now r dash of 30. So it's going to then be minus 11250 pi over 13 sine of, it was pi over 26 times t, so we're going to be replacing t there with 30. And then all you've got to do now is just make sure that this is going to end up being positive. So again, you can type that all into the calculator in one go. And again, make sure your calculator is in radian mode. So when you put all that into the calculator, we're going to get this. We're going to get 1,263.44. And that is certainly greater than 0. So what you can say then, you just say then that, so since first derivative of the revenue function is positive after 30 weeks, the revenue increasing 30 weeks after the beginning of July. Alright, and then part E then, it says find a value for the time t within the first 52 weeks when the revenue is at a minimum. Use the second derivative to verify your answer. Right, so we want to minimize the revenue here. So to maximize a function or to minimize a function, you're going to use differentiation. So what you do is you differentiate the function, or the first thing you do is you differentiate the function and then you let it equal to 0. That's the first thing you do. Then you check what the second derivative is to check whether it's a max or a min. So we're going to again use our first derivative here. So the first derivative was, what was it again? It was this here, okay? So the first derivative then is minus 11250 pi over 13 sine of pi over 26t. Now we're going to let our first derivative equal 0. So now we've got to solve this for t, right? So we can divide both sides by that constant, so then you're going to end up with sine of pi over 26 t is equal to 0. So this again goes back to sort of the unit circle here, but sine is going to be 0. Sine is going to be 0 when the angle is 0, also when it's pi, also when it's 2 pi, when it's like 0, 180 degrees, 360 degrees, and so on. So yeah, so pi over 26t here can equal, well, the first value can be 0. Again, this goes back to trigonometry. The next value would be like 180 degrees, but in radians that would be pi, or it could be 2 pi, etc. Alright, it's going to take a multiple value. It's going to be a multiple value of pi. So therefore, again, let's divide across by pi here again. So 1 over 26t is equal then to 0, 1, 2, and so on. So then multiplying across by 26. So t can equal then 0, or it could be 26 weeks, or it could be 52 weeks, and so on. That's going to be, this is going to be, these values are going to be either when the revenue is at a maximum or a minimum. Now, it says here, find a value for the time t within the first 52 weeks when the revenue is at a minimum. So, again, this is going to, we want to check, well, it's going to have to be one of these values, okay, because all of these values are within the first 52 weeks. So now we're going to be using our second derivative here, okay? So at a minimum, at a local minimum, the second derivative is actually positive, okay? So let's get the second derivative straight away, right? So we're going to differentiate our first derivative again. So here's the first derivative. We're now going to differentiate this. So we're going to do the same way that we differentiated earlier. That constant is going to stay there regardless. So we're going to have here minus 11,250 pi over 13. That constant is going to stay there. Then if you differentiate sine of anything, you're going to get cos of exactly the same thing. So cos of pi over 26t, but then again, what you have to do here is multiply then by the derivative of that angle. And the derivative of that angle is pi over 26. So again, what we're going to do now is we're just going to, tidy this up. So that times that, well, when you multiply that fraction by that fraction, it's going to end up being minus 11250 pi, or pi squared in fact, over 13 by 26, that's going to give us 338 cos of pi over 26t. Now, so that's our second derivative. Now, so we're going to use this to find out which one of these corresponds to the revenue being a minimum, right? So now, if you sub in, yes, we could sub in 0, all right? So if you sub in 0 there, that's going to be cost of, well, it's going to be cost of 0. And cost of 0 is actually 1. So if I sub in 0 into this function, that's going to end up being 1. 1 times that fraction is going to be negative because that fraction is negative. But remember, we want the second derivative to be positive, right? Let's sub in, well, let's try 26, right? So r dash of 26 is going to then be minus 11250 pi squared over 338 cos of, yeah, it's going to be cos of pi over 26 by 26. So that 26 is multiplied by the angle, multiplied by the pi over 26, and then you get cos of it. So pi over 26 by 26 is pi. Cos of pi, you'll find, would be minus 1. Minus 1 times that is going to give you then, well, it's going to, you know, the value of it is irrelevant, really, as far as we're concerned at the moment. What is relevant is the fact that it's positive, right? So that is greater than 0. So then that confirms then that hence the revenue is minimized when t equals 26 weeks. Alright, and if we put in 52 there, by the way, into the function, the second derivative, it would be cos of 2 pi, which again, cos of 2 pi, that would be back to 1. So the second derivative will be negative. So the revenue is actually maximized there, and it's minimized when t is 26 weeks. And that is question 8 completed.